Look at the phone in your hand. It might run on an Apple chip, a Qualcomm Snapdragon, a Samsung Exynos, a MediaTek Dimensity, or something from a brand you've barely heard of. These companies compete fiercely with each other. They spend billions on research. They fight for design wins. They argue about benchmarks. But here's the strange part. Underneath almost every one of those chips, there's the same foundation, the same architecture, the same DNA. And it comes from a company that doesn't manufacture a single chip. A company that doesn't sell the silicon sitting inside your phone. A company that, in many cases, you've never seen advertised. That company is ARM. ARM does not manufacture the chips in your phone. It licenses the blueprint everyone needs. So how does a company that owns no factories, ships no consumer chips, and stays mostly invisible end up as one of the most powerful players in the entire semiconductor industry? That's what we're unpacking today. Because the answer rewires how you think about where the money actually lives in tech. When most people picture the chip industry, they picture the obvious stuff. Giant fabs, clean rooms, EUV machines that cost hundreds of millions of dollars each. Tens of billions of dollars in capital expenditure just to keep up with the next process node. And yes, that part of the industry is real, and it's enormous. But it's only one slice of the pie. The chip industry is actually a layered ecosystem, and different layers make money in completely different ways. You have the manufacturers, the foundries like TSMC, Samsung Foundry, and Intel. They run the fabs and physically print chips on silicon wafers. You have the chip designers like NVIDIA, AMD, Qualcomm, and Apple, who design the chips but mostly outsource the actual manufacturing. You have the tool companies like Synopsys and Cadence, who sell the software that engineers use to design those chips in the first place. And then you have ARM, which sits in a category almost by itself. ARM doesn't sell finished chips. It doesn't even really sell finished designs in most cases. It sells the right to use its architecture and its processor cores. It's one of the clearest examples of an asset-light business model in semiconductors. Almost no manufacturing capex, almost no factories. And yet, an outsized influence on the entire industry. To understand why ARM matters, you have to understand exactly what it's selling. So let's get into that. ARM does not sell a CPU to Apple. ARM does not ship a box of chips to Qualcomm. What ARM sells is essentially two things. The first is an architecture license. This is the right to use the ARM instruction set architecture, the fundamental language a CPU speaks, to design your own custom processor from scratch. Apple has one of these. It's why Apple can build its A-series chips for iPhones and its M-series chips for Macs that are deeply customized but still ARM compatible. The second is a processor core license. This is for companies that don't want to design a CPU from the ground up. Instead, they license a ready-made core, like one of ARM's Cortex designs, and integrate it into their own system on chip. Think of ARM as a company that sells the design language and the engineering blueprint for a CPU. Some customers take just the language and write their own novel. Others take a pre-written chapter and slot it into their book. Either way, ARM gets paid. And those customers then take that foundation and tailor it for whatever they're building. A flagship smartphone, a budget tablet, a car infotainment system, a smart speaker, a sensor in an industrial machine, a processor inside a data center server. The same underlying architecture adapted in 1,000 different directions. This is the first big aha moment about ARM. It's everywhere, but it's everywhere by design, because ARM made itself the easiest, most flexible foundation to build on. It doesn't need a fab to be omnipresent. It just needs partners who do. Now let's talk about why why this is such a beautiful business. Building a leading-edge fab is one of the most capital-intensive activities on the planet. We're talking tens of billions of dollars per facility, constant upgrade cycles every couple of years, and brutal technological risk. If you bet on the wrong process node, you can fall behind for a decade. ARM completely sidesteps that part of the value chain. It doesn't pour money into manufacturing. Instead, it pours money into research and development, architecture design, intellectual property, and partner relationships. Then it licenses the result to dozens of customers, all of whom pay for the right to use it. The revenue model usually has two layers. First, there's an upfront license fee when a customer signs on to use the architecture or a specific core. Then, on top of that, there are royalties. Every time a chip using ARM's design chips in a product, ARM typically earns a small cut. Multiply that by billions of devices a year across phones, wearables, cars, and IoT gadgets, and you start to see the picture. One platform monetized over and over across countless customers and end markets. This is a model that scales beautifully. The more devices in the world that run on ARM, the bigger ARM's network gets, and the harder it becomes for any single competitor to dislodge it. ARM didn't just find a clever way to make money, it found a way to compound. To really understand why ARM became the foundation of modern computing, you have to go back to the rise of mobile. Inside a smartphone, raw performance is not the only thing that matters, and arguably, it isn't even the most important thing. What matters just as much is power efficiency, because phones run on small batteries. Heat dissipation matters, because phones don't have fans. Physical size matters, because every millimeter of board space is fought over. And integration matters because modern phone chips aren't just CPUs. They're systems on chip that pack the CPU, GPU, modem, image processor, and AI accelerators into one tiny package. ARM's design philosophy, from very early on, prioritized exactly these things. It was built around doing useful work per watt, not just maximum work at any cost. So when smartphones exploded in the late 2000s and 2010s, ARM was already sitting there with the right answer to the right problem. Apple, Qualcomm, Samsung, MediaTek, and others didn't really have a meaningful alternative. They built on ARM, and the entire mobile software stack, from Android to iOS to the apps inside them, evolved around the assumption that ARM was the foundation underneath. Once that ecosystem locked in, the network effects took over. Developers, tools, compilers, engineers, supply chains, partners, all standardized around ARM. And here's the elegance of it. ARM didn't have to win each smartphone by selling the chip inside. It won by becoming the platform standard that every chip maker had to use to compete in mobile in the first place. That's a much more powerful place to stand. So pause for a second and zoom out. If you're holding an ARM-powered phone right now, you didn't buy anything from ARM. You probably can't even find an ARM logo on the device. You bought from Apple, or Samsung, or Xiaomi, or whoever made the phone. They bought a chip from someone like Qualcomm, or MediaTek, or designed their own. And those companies are the ones paying ARM. ARM's real customers aren't consumers. They're the chip designers, the device makers, and the platform companies building the hardware ecosystem itself. ARM is the company in the back of the room, almost invisible, but absolutely essential. You don't see ARM on your phone, but a huge chunk of what your phone does works because of ARM's architecture. Which raises a much more interesting question. If ARM is just sitting quietly in the background, why do the biggest, richest, most aggressive technology companies on Earth keep depending on it? Why don't they just walk away and build their own thing? The answer takes us into the deeper layer of how ARM actually holds power. To see why, it helps to map out the chip industry as a stack of layers. At the very bottom, you have IP and architecture. That's where ARM lives. Above that, you have chip design, where companies like Apple, Qualcomm, NVIDIA, AMD, and MediaTek take that IP and build complete chip designs around it. Above that is manufacturing, the foundry layer, where TSMC, Samsung, and Intel turn those designs into physical silicon. Sitting alongside that is the equipment layer, dominated by ASML, Applied Materials, and Lam Research, who supply the machines that fabs use to make chips at all. And finally, on top are the end products, the iPhones, the Android phones, the laptops, the cars, the cloud servers. ARM sits very, very early in this chain. Its work happens before the chip is even designed in detail, let alone manufactured. If TSMC is the printing press of the chip world, and NVIDIA is one of the great designers writing books on AI silicon, then ARM is something closer to the alphabet itself. It's a foundational layer of the language that many CPU designers use to write their products. That position, low in the stack but central to everyone above it, is what makes ARM so structurally important. And it's the reason its kind of power is so hard to replicate. Here's the thing about platforms that sit at the foundation. They don't need to control the final product to control the game. ARM doesn't tell Apple how to design the iPhone. It doesn't tell Qualcomm how to position its Snapdragons, but it controls the layer that all of those products sit on top of. And once enough companies build their products on the same foundation, that foundation becomes incredibly hard to replace. ARM's leverage comes from a stack of advantages that reinforce each other. Ubiquity, because ARM is everywhere. Software compatibility, because the world's mobile software is essentially compiled and optimized for ARM. A massive partner network of designers, foundries, and tool vendors. High switching costs for any customer who wants to leave. And decades of accumulated expertise in low-power design that no one can replicate overnight. If a company decided tomorrow that it wanted to abandon ARM, it wouldn't just be swapping out a CPU. It would be rebuilding compilers, retraining engineers, recompiling software, validating drivers, requalifying its supply chain, and convincing its customers and developer ecosystem to come along for the ride. That's a multi-year, multi-billion-dollar project, and even then, success isn't guaranteed. This is a different kind of power than owning a fab. Owning a fab is physical power. You control machines, capacity, and output. ARM has something subtler, what you could call standard power. It's the power of being the default. And in technology, being the default is one of the most valuable positions you can occupy. But no platform is invincible. And ARM has real risks to think about. Whenever a single layer becomes this central, the rest of the industry starts looking for alternatives. The most talked about challenger today is RISC-V, an open instruction set architecture that anyone can use without paying license fees. RISC-V is still maturing, and its ecosystem is far smaller than ARM's, but it's growing fast, and some big players are investing seriously in it precisely because they don't want to be locked into one vendor forever. Beyond RISC-V, there's the issue of customer leverage. ARM's biggest customers are some of the most powerful technology companies in the world. They have deep engineering benches and deep pockets. If licensing terms get too aggressive, or if pricing pressure starts to bite into their own margins, those customers have options. They can push back hard in negotiations. They can quietly fund alternatives. A few of them could even explore building deeper custom solutions of their own. ARM also faces the question of where it grows next. Mobile is mostly mature. The exciting growth is now in data center servers, AI accelerators, automotive computing, and PCs, places where x86 from Intel and AMD has historically dominated, and where NVIDIA's GPU empire looms large. AMD's ARM has been making real inroads, especially in cloud servers and Apple's Macs. But the battle for the future of high performance and AI computing is far from settled. The big question hovering over ARM is whether it can stay central as the industry shifts from being mobile first to being AI first. And this brings us to the real insight at the heart of ARM's story. In the chip industry, the most powerful company isn't necessarily the one with the biggest fab or the flashiest product. ARM proves that you can build enormous power and enormous economic value by owning intellectual property, standards, and ecosystems instead of factories. Think about what that actually means. Apple, Qualcomm, MediaTek, Samsung, and dozens of others compete viciously with each other in the consumer market. They steal each other's customers. They undercut each other on price. They race to be first with the next feature. But many of them, despite all that competition, still need a common foundation to even show up to the fight. And that foundation is ARM. ARM doesn't need to bet on which one of them wins. It doesn't need to pick a champion. It just needs the overall market for connected devices to keep growing. And it gets paid no matter which brand ends up in the customer's hand. That is an extraordinary position to occupy. There's a useful way to picture it. Imagine a railway network. Lots of train operators run their trains across the country. They compete with each other on speed, comfort, and price. But all of them, no matter how fierce the competition, run on the same tracks. ARM, in many ways, is the company that owns the tracks. It doesn't have to be the fastest train. It doesn't even have to run a train. It just needs the trains to keep running. ARM doesn't sell the chip. ARM sells the platform that other people use to make the chip. Step back from the silicon for a moment, and eARM becomes a case study about something much bigger than chips. It's a case study about where value actually accumulates in complex industries. You don't need to own the most expensive piece of the value chain to capture the most strategic part of it. You don't need to own a fab to shape the semiconductor industry. ARM competes instead with design talent, intellectual property, ecosystem leadership, and standards. The advantages of this model are clear. It's lighter on capital. It scales beautifully across markets and customers. It generates recurring royalty streams that compound as the device universe grows. And it puts ARM in a structurally central position that's very hard to dislodge. But the risks are real too. Platform businesses depend on the ecosystems they enable. They face pressure from large customers who'd rather pay less. They have to fend off open alternatives like RISC-V, and they have to keep evolving to stay relevant as the industry's center of gravity shifts. The deeper lesson, though, is that in a layered value chain, the money doesn't only live in the finished product. It lives in the platform that everyone else has to build on top of. Whoever owns that platform, whoever defines the standard, often ends up with a quieter but more durable kind of power than the companies fighting for attention at the surface. So here's the question I want to leave you with. In the chip industry, who actually makes the most money in the long run? Is it the designers who shape what chips can do? The manufacturers who turn designs into silicon? The equipment makers who supply the machines that make all of this possible? Or the IP holders, like ARM, who quietly own the foundation everyone else stands on? Drop your answer in the comments and tell me which company you want broken down next. TSMC, NVIDIA, ASML, Qualcomm, Intel, AMD, or even RISC-V itself. If you want more deep dives like this on the business models powering the chip industry, subscribe and stick around. Next up in this series, we're going inside TSMC, the foundry that quietly makes chips for almost the entire world, and ASML, the company that builds the one machine the entire semiconductor industry can't live without. I'll see you in the next one.